Welcome. Today we introduce Eratosthenes, the Hellenistic polymath, the extraordinary mind that organized the chaos of the ancient world. Through geometric precision and relentless curiosity, his intellectual achievements laid the groundwork for modern measurement, geography, and scientific inquiry, transforming how humanity understood the classical universe. Born in 276 BCE in Cyrene, a vibrant Hellenistic hub under Ptolemaic rule, Eratosthenes grew up at a prosperous crossroads of Greece, North Africa, and the Persian Empire. Fueled by the export of horses and the prized medicinal plant silphium, Cyrene offered a thriving intellectual environment. Here, under the guidance of the renowned grammarian Lysanias, Eratosthenes received his early education, laying the critical foundation for his future mastery of classical philology and literature. Eratosthenes of Cyrene earned the nickname Pentathlos, an athletic title for one who excels across multiple events, because his intellect spanned all known disciplines of his era: geography, mathematics, astronomy, history, and poetry. Serving as Chief Librarian at the renowned Library of Alexandria, he applied mathematical and proportional frameworks with relentless precision to decode physical reality, cementing his reputation as one of the ancient world's most versatile masterminds. Known as the father of geography, Eratosthenes revolutionized how humanity understood the physical Earth. By applying pure mathematics and geometric principles to spatial measurement, he successfully mapped the ancient world. His pioneering work transformed geography from simple descriptive accounts into an exact science, laying the structural groundwork for modern cartography and spatial grid systems. Eratosthenes famously rejected Homer's mythic worldview, separating poetic imagination from empirical science. While Homeric topography was narrative-driven, unscaled, and intended to entertain the soul, Eratosthenian geography introduced a geometry-driven, scaled, and universal framework. By asserting that poetry seeks to entertain, while science aims to instruct and measure, Eratosthenes replaced heavily mythologized tales with a mathematically bounded understanding of the world. To measure Earth's circumference, Eratosthenes compared sunlight on the summer solstice at two distinct points. In Syene, the sun shone directly down a well, casting zero shadow. In Alexandria, 5,000 stadia north, a pole cast a 7.2-degree shadow, exactly 1/50th of a circle. Applying alternate interior angle geometry, Eratosthenes calculated Earth's full curvature to be 50 times that distance, 250,000 stadia, or approximately 40,000 kilometers. By calibrating the planet through elegant geometry, he unlocked the fundamental key to accurately scaling two-dimensional maps. To organize cartography, Eratosthenes constructed the first global projection using a mathematical scaffolding of intersecting lines, the direct precursors to modern latitude and longitude. He established an east-west primary parallel stretching from Gibraltar through the Mediterranean and Rhodes to the Indus River, intersected perpendicularly by a north-south primary meridian passing through Meroe, Syene, Alexandria, Athens, and Byzantium. By imposing this grid onto the globe, he transformed spatial mapping into an ordered, systematic discipline. To map the oikoumene, the known inhabited world, Eratosthenes conceptually sliced the spherical Earth to isolate where human civilization was physically possible. He compared this habitable belt in the northern hemisphere to a spondylos, the small, circular weight used on a spinning wheel. Bounded between the freezing extremes of the far north and the blazing heat of the equator, this isolated zone clearly defined the spatial limits of human existence, turning geographic theory into a precise model of world habitability. Welcome to the oikoumene, humanity's first global canvas. Drawing upon the polar voyages of Pytheas, Eratosthenes stretched his map northwest to Bretagne and Urn. To the east, he incorporated military logs from Alexander the Great's campaigns, extending geography's reach to the Indus River and Taprobane. Within his monumental work, Geographica, he cataloged the names and estimated coordinates of over 400 cities. An unprecedented feat of data aggregation that transformed disparate accounts of exploration into a unified, scientific vision of the known world. By applying solar geometry, Eratosthenes divided the globe into 5 distinct climate zones, establishing a macro view that informed exploration for centuries. At the extremes lie 2 freezing, uninhabitable polar zones, while a blistering tropical zone spans the equator. Between these environmental extremes rest 2 temperate zones, the Spondylos belts, where human civilization thrives. This systematic classification brought mathematical clarity to global climate and human habitability. Replacing imprecise continental divisions, Eratosthenes classified regional territories using sphragides or sealstones. By modeling land masses as irregular geometric quadrilaterals bounded by rivers and mountains, he transformed complex geography into calculable shapes. Under this framework, Mesopotamia was measured as a galley formed by the Tigris and Euphrates, Iberia as an ox hide, and the Peloponnese as a plain leaf. Through these geometric abstractions, Eratosthenes brought mathematical rigor and spatial order to the mapping of empire. By combining his calculation of Earth's circumference, intersecting primary axes, solar climate zones, and geometric sphragides, Eratosthenes created a complete, calculable system that transformed geography from poetic myth into an exact science. His enduring polymathic grid established the bedrock of global spatial measurement. More than 2,200 years later, every time we drop a pin on a digital map, we continue to utilize the foundational mathematical framework invented by a librarian in Alexandria. Eratosthenes of Cyrene, third chief librarian at the Library of Alexandria, known as Pentathlos, for his all-around mastery across multiple disciplines, confronted an ancient world tangled in competing calendars, unmapped stars, and contradictory historical myths. To overcome this chaos, Eratosthenes imposed a systematic, mathematical grid over physical reality, transforming a disparate world into a measurable universe. Around 255 BCE, Eratosthenes transformed astronomy by creating the armillary sphere, a mechanical sky representing the first physical grid imposed upon the heavens. Before his breakthrough, the cosmos was merely observed. With this analog mechanical model, it could finally be modeled and predicted. By enabling early astronomers to trace and forecast the apparent motions of the stars along the celestial equator and the ecliptic, Eratosthenes turned skywatching into a precise, predictive science. In his katasterismi, meaning placings among the stars, Eratosthenes mapped myth directly onto a mathematical canvas. By systematically harmonizing the ancient Mesopotamian zodiac with classical Greek mythology, he transformed cultural folklore into ancient Greece's first preserved star catalog. Charting exactly 675 stars onto a celestial coordinate grid, Eratosthenes bridged the divide between story and science, turning poetic sky lore into structured astronomical data. To correct Earth's temporal rhythm, Eratosthenes devised a calendar based on precise mathematical predictions of our orbit around the Sun. He calculated that a true solar year spans 365¼ days, demonstrating the necessity of adding an accumulated 366th day every 4th year to remain synchronized with the cosmos. Predating the Julian calendar reform by over a century, this leap year correction laid the structural mathematical foundation for the Western solar calendar, harmonizing human timekeeping with the motions of the heavens. To standardize human history, Eratosthenes introduced scientific chronology in his monumental work, Chronographiae. Replacing isolated, contradictory regional king lists, he constructed a universal linear timeline through a diastematic dating method. By calculating precise mathematical intervals between recognized historical landmarks, such as 80 years between the fall of Troy and the return of the Heraclidae, he established a continuous temporal grid. Anchored by calculating the fall of Troy in 1184/1183 BCE as an absolute starting point, Eratosthenes transformed historical record-keeping into a measurable, computable science. Eratosthenes transformed raw mythos into scientific logos, bringing structural order to both space and time. In the heavens, he replaced disconnected stellar folklore with the armillary sphere and a catalog of 675 plotted stars. Across human history, He resolved contradictory king lists and unpredictable seasons by introducing the leap year calendar and a diastematic linear chronology. Ultimately, Eratosthenes' true genius was not merely making isolated discoveries, but inventing a universal methodology of systematic measurement to map the architecture of reality. More than 2,200 years ago, a single mind in Alexandria brought mathematical order to both the heavens and human history. Today, we still live by the grids Eratosthenes constructed. His foundational work gave us the exact coordinate system that guides modern GPS, the leap year calculation that synchronizes our digital calendars, and the linear timeline that structures human history. From planetary navigation to temporal tracking, we continue to navigate reality using the enduring blueprints of the Pentathlos. To isolate prime numbers without endless division, Eratosthenes invented his famous sieve, an ancient, remarkably efficient algorithm of iterative marking. By selecting a prime and systematically crossing out its multiples purely through addition, he transformed a daunting mathematical challenge into an elegant, calculable process. In sifting the infinite to reveal hidden numerical order, Eratosthenes created a breakthrough that continues to serve as a foundational algorithm for prime number generation in modern computer science. To isolate prime numbers without endless division, Eratosthenes invented his famous sieve, an ancient, remarkably efficient algorithm of iterative marking. By selecting a prime and systematically crossing out its multiples purely through addition, he transformed a daunting mathematical challenge into an elegant, calculable process. In sifting the infinite to reveal hidden numerical order, Eratosthenes created a breakthrough that continues to serve as a foundational algorithm for prime number generation in modern computer science. Turning his focus upward, Eratosthenes anchored the heavens with mathematical precision. He calculated Earth's axial tilt, the obliquity of the ecliptic, at 23 degrees 51 minutes 15 seconds, coming within a staggering 7 arcminutes of its actual value. In his work Katasterisme, he compiled a precise catalog of 675 stars by fusing rigid Mesopotamian coordinate astronomy with Greek mythology. By anchoring legendary folklore directly to physical cosmic coordinates, Eratosthenes mapped the celestial realm with unprecedented accuracy. Across 4 dimensions of measurement, Eratosthenes systematically transformed impossible problems into precise geometric solutions. In number theory, his sieve isolated infinite primes. In solid geometry, his mesolabio doubled the cube using continuous proportionals. Scaling upward, alternate interior angles unlocked Earth's 250,000 stadia circumference, while ecliptic proportions mapped a 675-star coordinate catalog across the cosmos. By finding proportion between the known and the unknown, Eratosthenes demonstrated that the entire physical universe operates as a master geometer's blueprint. Eratosthenes of Cyrene was far more than a mathematician, librarian, or poet. He was the ultimate philologos, a mind that refused to be compartmentalized. By dismantling the barriers between the sciences and the humanities, he seamlessly unified human knowledge. In doing so, the Pentathlos provided the ancient world with the foundational blueprints it needed to measure, order, and truly understand itself, leaving behind an enduring legacy of polymathic inquiry.